Hey everybody, and welcome to the activity walkthrough for lesson 4. So I mentioned in the lecture that we're going to be learning about how to use objects, how to instantiate them and invoke their different behaviors and use them to get the job done in our program. This is actually going to be the first activity where we have more than one Java file in our program. We're going to have the minifig class, which we're going to use to create minifig objects, which you'll actually be able to invoke a draw behavior on them, a draw method, and it'll actually pop up a window and draw a little Lego dude, just like this. And so, if you recall, a class in Java is like a blueprint for an object, outlines the different attributes and behaviors it's going to have, and from that class we can instantiate a multitude of objects, however many we need, and we can then use them in our program. And so, to get started with this activity, you're going to have links to two Java files here. You're going to need to open them both, and we're going to import them into Eclipse. So I'll show you what that means here. So if we click that guy, the link should pop up, and it'll open in a new tab. So this is the minifig class, and then this is the myavatar.java. Now this myavatar.java is actually where you're going to be doing the work in your program. Minifig is already completed for you, so that's the class that you're going to use to create your minifig objects. But first and foremost, we need to import both of them. Depending on which browser you're in, Chrome or Firefox, when you click that link, it might download the file immediately. If you're in Firefox, at least on a Mac like me, it just opens the page. You can either Control-A to select everything and copy it and paste it into a Java file, but then you have to worry about naming it correctly and everything. So what I like to do is I just like to right-click and hit Save Page As. Pop up a window. I'm just going to save it in my downloads, and I'm going to call it myavatar.java. And notice it's a plain text file. So by putting that .java on the end there, I just saved it as a Java file. You right-click on minifig and do the same thing. A .java file is really just a plain text file with the .java extension, because source code is just plain text. So, and by plain text, really what that means is it's just the simplest text document you could have. You know, Microsoft Word documents and stuff have a lot of extra formatting in there. Plain text, it's literally just characters in a file. So, super simple. So now that we got those saved, we can go to our activities 04 and 05 project. Now to import files, you can either right-click it or you can go up to this file, both work, and click import. Make sure you have the right project selected. And it's going to give you some different options. When you open it, it'll probably look like this. What we're doing is very general, so you'll expand the general drop-down, and you'll select File System, because we saved those files onto our computer, so we're going to import them from our computer's file system. Go ahead and click Next. It's going to ask you what directory you want to import them from. So let's go and select Downloads. Now this is the weird thing. Notice you can see minifig.java and myavatar.java, but they're grayed out. It's because we need to select the directory we want to import from. And so we selected downloads over here. We're going to hit open. So this is going to open the directory, and now we can select the files that we want to import. So in that menu, select the two files you want to import into your project and hit finish. And now they'll pop up. Awesome. So let's open both of these guys. Now they're going to look kind of intimidating. There's a lot of code in there, but you don't have to touch any of it. There's some comments, and going through and reading these comments might really help you with understanding classes a little better, kind of give you a sneak peek into what we're going to be learning when we talk about writing our own classes. But for now, we're just going to follow the project directions, kind of ignore all this extra code, and only be concerned with what we're learning right now. Now that's one of the hard parts about CS 121, I know. There's just so much to learn, and we try to guide you through directions in our activities and what we do and what we cover in the slides to kind of introduce you to this stuff slowly. But you can go ahead and look ahead if you want to. So again, the activity specifications are where we're going to find what we need to do to successfully complete this activity. Now this is the first one where, to really get the idea of what you need to do, this is the first activity where we have to look at the code and the comments in the code, and we have to look at the directions in the activity. It's kind of get your instruction from both places. They're kind of the same directions, but they say things in slightly different ways, so it's important to read it both in the code and on here. What do I mean by in the code? It says, for each of the following steps, follow the directions in the to-do comments listed in myavatar.java. And then step 1 is instantiate a new point object. So we need to find these to-do comments in our code. Now, what is a to-do comment? Let's go to myavatar.java, and something really cool, if you hit Control F, or on a Mac, Command F, there's a find box. So let's look for to-do. So there's the first one. Now, to-do comments are actually really special in Java programs. Again, remember, a comment begins with 2 slashes and then a space, and you start your comment. A multi-line, that's a single line comment, so notice they had to put 2 new slashes down here to finish it. You've also got a multi-line comment up here that starts with the /* and then ends with the */. And remember, comments are for us, humans, programmers, to read and to be informed about, usually when you're writing code, what the code is doing. And in this case, we're using comments to direct you, the student, on what to do in each step of your program and where to do it. So remember, the comments don't get compiled into the code, so as long as we comment off our comments appropriately and we don't forget 2 slashes like that, we're good. And to-do comments, as I was saying, are very special because we actually use them, it's literally as like a to-do on a to-do list. So if I'm writing code at work and there's something, I run into something that I want to fix, but I don't want to fix it right now, often I'll leave a to-do comment as a reminder myself to do it later. They're easy to search for because no Java code, except for a to-do comment, is going to have all caps to do. So you can just search for those really easy in your whole project and kind of find stuff that you need to fix up. Now, this is where we're going to start doing our code, and it says, just like the directions, instantiate a new point object called anchor, use mid as your x value, and top as your y value. So again, this to-do comment has some extra instructions that the directions in our activity really didn't have. So that's again why it's important to read the to-dos and the activity directions. So let's go back to the code. Now, where are we in the code right now? You can see we're pretty far down into the myavatar.java file, and the answer is we're in this paint component method. Now again, we haven't talked about how methods are built, so I don't expect you to know what all this, just minimize it, all this stuff right here means. But just know that we're in a method, so we're in the behavior of this myavatar.java class, and myavatar.java class does have the main method in it, but you can also have other methods in your class with your main method. And so in this case, the main method's in here, and it starts the program, but it's going to end up calling this paint component method, and it's actually what's going to draw the whole minifig in that little window that gets popped up. So the method that we're working in is the code that's going to be used to actually draw our minifig guy. So pretty cool. But let's go back to our to-do. So we need to instantiate a point object called anchor. So, and keep in mind, point is the name of the class, it's the type of object it is, but it's also the type with which we're going to refer to the object. So if I want to instantiate, if I'm told I need to instantiate a point object called anchor, the first thing I'm going to do is I'm going to get my declaration going. So I know it's going to be a point, so that's the type we're going to have. And then we're going to call it anchor, so that's the name. So anchor. And remember, I could just do that and end my declaration there, and then I could say later on in code, anchor equals new whatever, right? I'm going to instantiate it though. It says instantiate, so that tells me I'm going to declare it and create or instantiate it at the same time. So use mid as your x value and top as your y value. Now, if you hover over this constructor here, should pop up, or maybe, well, first we have to import it. That's why Java's mad at us, so let's go ahead and import it. Put a semicolon there for good measure. Now remember, in Java, all your lines of code have to end with a semicolon, so don't forget that. And if we put our cursor here and kind of hover, it should pop up with our parameters for our constructor. Construction initializes a point at the origin 0, 0 of the coordinate space. Oh, so we need to pass in parameters. Otherwise, this is valid, but it's just going to create a point at 0, 0. So remember, point constructors take the x value and then the y value. Now, what are mid and top? If you look up above a little bit, those are variables that just got created. This is the anchor point for minifig, x and y, mid and top. Now, you're going to find that current width is actually going to be the width of that window that the minifig's getting drawn in. So these are literally calculating the coordinate points for our minifig on that little window. And that'll be more apparent when we actually draw our minifig. But just for now, know that when we draw this little guy on those pop-up windows in a Java graphics window, that the places, the locations that things get drawn are actually coordinate points. So it makes it really easy for us to figure out where we're going to draw things. So let's put mid and top in there for our x and y values. And that's our to-do number 1. Let's go back to our directions. To-do number 2, instantiate a new minifig object. Here's the documentation for the minifig class. Well, if we're going to be working with the minifig object, it's going to be really handy to have the documentation. So let's open that up. Now, I mentioned Java docs before in our first lecture on objects, and this is actually what, when you use those special Java doc comments, this is actually what those comments get generated into. So the instructors who wrote the minifig class put some really detailed comments, and we actually have really good documentation of our minifig's different attributes and its different behaviors. So here's actually what it's going to look like when he gets drawn. He's going to get drawn in this little window. And you can see these are method names. These method names are actually going to return to you the different points. So like get base midpoint is going to return to you this point here, the midpoint on the base of your minifig. And that's going to be the x and y coordinates for that point. Scroll down, let's take a look at the methods. Get base midpoint returns a java.awt.point. Remember, this is what we call the fully qualified class name for the object. So that's the name of the class, point, with also the package that it's in on the end of there. It's kind of like files in a file system. You've got Java, that's super high level one, obviously. That's the very high level package. AWT, I believe that's stuff for like drawing things, if I'm not mistaken. And then I think it stands for Abstract Window Toolkit or something like that. And then you've got the point class, the actual XY point. And then here's the method name right here. So get base midpoint is going to return the point x and y, representing the bottom middle of the minifig. So if you look at this, when we're drawing our guy, these methods are going to be really helpful for figuring out where we want to draw him, how big he's going to be, and stuff like that. Let's go back to the activity directions. We're going to instantiate a new minifig in step 2. So let's scroll down, read the to-do on step 2 before we do anything else. Instantiate a new minifig object and give it a reference variable, the name of a person, such as Bob. Use the minifig constructor with the following parameters. So they're actually telling us how we're going to use the minifig constructor. So again, parameters are going to come later. We're going to learn more about how constructors work, so don't worry about that too much right now. Really, we're just learning how to use objects and how to start working with them. So don't be worried if a little of this feels a little hand-wavy and like you're just following directions. That's how it should feel, because that's what you're doing. So I'm just going to call my minifig Bob, just like it says. And remember, we're giving our object reference a type, minifig, and Bob. So Bob is going to refer to the new minifig object we're creating right now. We're going to give it G, scale factor. These are already variables that you've either created, like anchor, or that already exists in the program, like G and scale factor, so don't worry about that. And now we're on step 3 already. Create a new custom color object. An example is shown below. And step 3 in the directions just says instantiate a new color object. So now we're working with another kind of object. In Java, we have a class called color that helps us work with colors, literally like colors that you'll see. And when we draw our minifig, you'll actually be able to change the color of the different parts of his body. So let's scroll down and see if we can find that color example. Awesome. So we've got color grass green equals new color, and you can see the color constructor here. Now, the color constructor is really cool. It actually takes in the red, green, and blue color values of your color. So the first thing I'm going to do, and feel free to do this, you don't need to feel like it's cheating, is I'm just going to copy this instantiation right here. I'm going to paste it, and this is going to be my new custom color. Notice when I go down here, if I don't change the name, it's going to say duplicate local variable grass green. Well, we're already using grass green down here, so we definitely want to keep grass green this color. So we need to change the name of our color object so we don't have a duplicate variable. So I'm just going to call it my color. Using that good variable naming, camel case, my color kind of tells us that it's a custom color. Now, I said red, green, blue values. For those of you that are maybe in the graphic design or artists out there, you know what that means. But if you're like me and you didn't know what it meant until CS121, let's get into it a little bit. So, if you didn't know, you can make any color in the rainbow with just red, green, and blue values. So if I go to color picker in Google, it's actually going to have this really cool slider where you can choose different colors. Let's make our guy like a cool kind of teal. Slide it around. I think that's teal. I don't really know. I'm not a very good color picker. But it's made up of the colors. This color is made up of different red, green, and blue values. And in programming and in graphic design, those values go from 0 to 255. That happens to be because you can represent the numbers 0 through 255 with 8 bits in a binary number. So the biggest 8-bit binary number we can have, 1111111111, is the number 256. Wait. No, that would be 255. You can represent 256 different values, but because we start counting at 0 in computer science, we can represent 0 through 255. So these three numbers here are never going to be less than 0 and never greater than 255. So let's actually copy those values in, and you can create and choose your own color into the color constructor for our minifig object. I'm going to paste those guys in there. Go ahead and save that. And now we can proceed. We've created our custom color object. Java's happy. Notice you're getting a little warning here. It's just telling us that the value of the local variable, my color, is not used. So what that means is we're just not using that variable anywhere else in the program. We've created it and we're not doing anything. You're going to get the same warning on our minifig Bob. When we when we invoke Bob's draw method, though, that warning will go away, and when we use my color to set his color of something, it will go away as well. So let's go back to the directions on our activity. Invoke the set torso color method on your minifig object. This is an example of a setter method. So cool. So we talked about setters in the lecture a little bit. Now this is actually going to allow us to change our minifig Bob's torso color attributes. So when we draw him, his shirt is going to be whatever color we created. So step 4 in the to-dos says invoke the set torso color method on your minifig instance. Use your color object as a parameter to change the shirt color. This lets you change the color of Bob's shirt. Smiley face. Oh. Instructors had a lot of fun when they were writing these comments, putting the smiley face in there. So if you recall, we invoke methods on our objects. So you could also say we invoke their behaviors. But we like to say invoke a method because that's actually what you're doing. You're calling that method or that procedure. So we invoke methods with the dot operator. So what I like to think of when I'm doing this is I'm like, hey Bob, set your torso color to this color I'm giving you. I'm going to pass it in my color. And perhaps we should give this variable a better name, because my color is not very descriptive. Let's call it actually torso color. If you click into your variable, get your cursor somewhere inside the variable name, and you right click, you say refactor, which is just a fancy programmer word for change. If you go to refactor, these are all change options that you can use on this variable. We're just going to say rename. And let's call it torso color. And notice it changes all the places we use this variable, so we don't have to go and find usages and change it. At work, I've done changes that are like 50 plus lines with one refactor, just like that, changing a variable name. In this case, we changed 2 lines. So now we're saying, Bob, set your torso color. We're invoking that behavior. And we're setting it to this guy. And this is another example of a parameter to a method. So remember, our methods are like functions in math. Sometimes they don't take parameters and they just give us a value, or maybe they don't do anything. And a lot of times they will take in a parameter and change an attribute or something on our object. So now we're on step 5. Invoke the draw method on your minifig instance. This is where Bob is displayed on the screen. And let's go and double check, make sure we're not missing anything in the instructions in the activity guide here. Invoke the draw method on your minifig object. Cool. So again, I just like to read both. I know the to-dos in the code are pretty descriptive, but sometimes the activity guide will have something in it that the to-dos in the code don't. So now we're going to invoke the draw method on our minifig instance. So again, we're going to use that dot operator, and we're like, hey Bob, draw yourself. Before we run our program, I think this is a good time to review return values on methods, because remember, sometimes methods will give you a value back. But in both of these cases, set torso color and draw, our method doesn't actually return anything. And let's go look at that minifig documentation. I talked towards the end of the last lecture about return types and how to read documentation. But if you look, we talked about that get base midpoint method, right? And how this is the column of what this tells you what the method returns. This tells you the name of the method, and this is a little description of what the method does. So notice get base midpoint gives to us a point object. It returns a point object to us. But both draw and set torso color return void. What does that mean? Well, it actually means that it doesn't return anything. It doesn't give a value back to us. We just invoke it, and it goes and does the thing. Because if you think about it, why when you're setting something would you need to get a value back? It doesn't need to give you back the value that you set it to, because you already know what you're setting it to. Otherwise you wouldn't have been able to pass it in as a parameter. It also doesn't really make sense for it to give you back like the old value, because obviously you're resetting it. You don't care about it anymore. And so same thing with the draw method. It's just going to draw your minifig. There's no reason to return a value there. So we return void. We don't return anything. And that's where you get that error if you were like, int return ret val, for return value equals bob.draw. Java's going to give you an error. It's going to say type mismatch, cannot convert from void to int. So void is a valid type in Java. It means no type, essentially. And you can't assign that into an int. So I'm going to go just Control Z that, undo it real quick, hit save. Now remember, if you modify your code, notice that little asterisk up there. It's going to tell you your file's unsafe. Make sure you save before you run it. But now we're ready to run our My Avatar program. So if you go up here to Eclipse and you click that little green run button, might take a second. It takes a second on my MacBook, but it's going to pop up a window and you're going to see Bob. So pretty awesome. There's the torso color. There's the color that we created. I think he's like dark blue by default, so I set it to like a kind of grayish teal. Now, another really cool thing about what we do in CS 121 is all of our drawings are scalable, so they'll actually grow and shrink if we drag the window around. Notice there's a problem with Bob though. You make it bigger, he starts to sink into the ground. I think he's standing on some quicksand. If you make it smaller, he apparently has some magical powers, and now he's levitating up in the sky above the ground as he gets smaller and smaller. So that's a problem. We want Bob standing on solid earth all the time, not mushy quicksand and not floating off the ground. So the next couple steps are going to help us resolve this issue. And if you close out of that, it actually terminates the program. You can see that's gone. And if I run it, you can see while that window's popped up, you can tell the program is running. Pretty cool. So, and this is really cool. We're going to work with graphics a lot in CS121 just because they're fun and it's easy to see the output of your program. It's a little more rewarding than just like printing something out to the console. Surely it wouldn't have been, this wouldn't have been as fun of an activity without being able to see little Bob pop up on the screen like that. So let's go back to the activity directions. I do like to read those first before I read the to-dos. So we're going to invoke the getBaseMidpoint method on your minifig. This is an example of a getter method. So again, referring back to those getters and setters that we talked about, torso color is an attribute of Bob. It's definitely probably a private instance variable inside the minifig class. And when we set it through that setter method. Again, remember that value is, since it's probably private, is encapsulated, so we have to use the setter to do it. We can't just say .torso color and change it. We need to ask Bob nicely to change his torso color. And same thing with the getBaseMidpoint method. That's going to give us that base midpoint value back, and that's how we're going to interact with that attribute of Bob. Get it through that method. We're not going to just go in and reach in directly. Got to ask Bob nicely to give us his base midpoint back. So we're going to do that for step 6. Let's read the directions here. Looks like there's definitely a lot more instructions on this to-do here, so let's read it. Oh, adjust the size of your avatar's window. He doesn't stay grounded on the grass, so we already have shown that. We're going to use that base midpoint method to find the base midpoint of your minifig. Returns a point object that references the XY coordinates. Awesome. Replace the hard-coded value of grass Y offset with the Y value of the return point. Whoa, so we've got kind of two parts to this step here. The first one is we need to get that base midpoint. So let's go ahead and do that. So this is going to be a point object, and let's call it base midpoint. And we're going to set it equal to Bob's base midpoint. So remember, because getBaseMidpoint returns a point object reference to us, we can assign that returned value, that returned reference, into a point reference. So here we're actually saving. Remember, this isn't the actual value of the point. It's not like this base midpoint variable actually contains the XY values in it. Remember, it's a reference. So this points to where those values are actually stored in Java's memory. So somewhere Bob's base midpoint is floating around inside Java's memory. This getBaseMidpoint method returns a reference to that point for us, so we can go get it and manipulate those values. So again, just kind of reminding you of the difference between objects and primitive types. And now we're going to replace the hard-coded value of grass Y offset with the Y value of the return point. Now this is a very important term in computer science. We use it all the time at work. It's used all the time in your undergraduate career. And what it means to hard code something is when you actually type a value into the code. So notice that this 400 here, it's not user input that we've collected and we turned into a number and now we're like, this is what the grass Y offset is. It's actually literally a number typed into your program. A really good example of hard coding something was when we wrote our temp converter program. And to change the value in Fahrenheit that we were going to convert into Celsius, we actually had to change the code, recompile it, and run it. That's in contrast to the convert hours, minutes, and seconds program we wrote in the next lesson, where we actually got that input from the user of how many seconds we wanted to convert. So that was an example of a dynamic program. So we want to be dynamic whenever we can. In this case, what setting grass Y offset to the Y value of this midpoint is going to do for us, it's going to keep that grass anchored to Bob's feet no matter how big or small the screen gets. Bob is already scalable. That's something that the minifig, our instructors worked really hard to make him scalable, so when you drag the screen around, he gets bigger or smaller. So keeping the grass y offset anchored onto the minifig's feet is going to be our best bet to keep them grounded on the ground. So now we need to get the y value of the return point. So remember, point objects have a get y value method. So we could do get base midpoint dot get y. However, and so remember, this is a point reference, so we can invoke methods using that dot operator on it. But if you recall, the methods to get y and x values from our point return doubles, and we're trying to save it into an int. So this is an example of a narrowing conversion. This is something we can't do without a cast in Java, because Java's worried. They're like, yo, you're saving a double, which is a really big data type, into an int, which is a smaller one. So if there's a decimal point on this value, which there won't be because I believe points are usually whole numbers, but if there was a decimal value, it would get cut off, it would get truncated. And so to make this work, you actually have to force it with a cast. This is an example of some pretty ugly code right here. Like, whenever you do a narrowing conversion, I mentioned that in my lecture about data types and expressions, you kind of should get a bad feeling. It's something that we would actually call a code smell in computer science. Code smell is when it's like you read something, it just kind of gives you that feeling, kind of like smell something bad. You know, it kind of tells you maybe you should think about doing something a different way. But also remember that points are unique in that their x and y attributes are not encapsulated. We can actually access them directly without calling a method. We went over this in the last lecture video if you need to remind yourself. And you can access them with the dot operator directly. So we can actually just do this. And remember that returns it as an int. So this is a much cleaner way to get the y value out of our base midpoint and assign it into this int value. I really do think, in addition to just simplicity, this is one of the reasons why they left those x and y values unencapsulated in the point class, is to have two different ways to get it, and each returns the different data type depending on your needs. So I think that's really, really cool. So let's go ahead now and run our program, see if Bob stays anchored on the ground. And indeed, he is firmly planted. You could say Bob is a pretty down-to-earth dude. So let's go and check out step 7, which I guess is a new section and now labeled number 1, not to be confused because it's called step 7 in the code. I apologize again. This is why it's important to read both the instructions and the to-do comments. So for this step, we're going to create an alias. So it asks us to create an alias for our minifig object and change the torso color of our alias. What happens when you draw your original minifig? And there's actually a really good example of this in the code here. So I'm actually just going to copy this and do the same thing that it does here. Step 7, it asks you to do the same thing. And what's really cool is they already have the code written for you. Excuse me, you can actually just uncomment it. So remember, I used my cool rectangle and dope rectangle example in the lecture. We've got minifig Robert equals Bob. So we created an alias to Bob. Remember, Robert doesn't create a new minifig object. He just references Bob. So now we just have two different names for the same object. Remember, I really like that example from the slides in the notes section where it says, if I tell you all my address in this video, I live on 777 West Main Street, Boise, Idaho, 83706. I believe that's the address of the computer science building. 30 people know my address. I don't get 30 new houses. We still have that one house. And so when we set Robert's torso color, we're actually going to get Bob's torso color changed as well. So in to-do number 8 down here, comment out the draw statement under to-do item number 5, and then draw the original minifig below. Now remember, it's important that we comment out the draw step on number 5, because if we draw them here, it's just going to draw the original one and we won't see the new one. So it's important that we comment that guy out. That's another really handy thing you can do with comments is if you want to kind of mess around with your code, but you don't want to erase it, just comment it out, write some new code, and then when you're done, delete that code you wrote before, that code you wrote later, and then just uncomment the code you had before, or flip-flop the comments. They're a really handy way of causing code to not get run, and but not having to delete it. So again, a nice little development trick. So let's uncomment this statement. Now, you see me hitting backspace, I really shouldn't be doing that. If you highlight it and then hit Control/ or Command/ if you're on a Mac, it'll actually uncomment it for you. Although I guess it doesn't change the indentation, which is kind of annoying. So you see me correct that indentation there. So we created our alias to Bob, named it Robert. So now we have 2 references. We invoked set torso color on Robert, and we set it to red, which I'll talk about this because it's a little different than those RGB values we saw. And now we're drawing Bob, and we'll see what torso color does he have. And it's red. Now remember, this is kind of like that example I used where if I told somebody my address on Monday, my house was painted gray, and then I painted my house blue, and I told you my address a couple days later, and then you both came to my house that weekend, my house would be blue, right? It's not like the first person I told is going to come and see a gray house. It doesn't work that way. That's the same way it works with object references. So even though we changed the torso color of Robert, we drew Bob, the shirt's still red. Pretty cool. And this right here is a handy way of accessing different colors without having to do that custom RGB value. That's pretty cool, but it's kind of hard, and you know, if you just need to create a color really fast, if you just need to have a color, you don't really care about it being a cool fancy color like I don't know, burnt orange, and you just want a nice primary color, you can do the name of the color class .red, and what that does is red is actually an attribute of the color class. It's a static attribute, which means we don't have to have a color object. We can just call it with the name of the class. We'll talk about that in, I think, like 2 lessons from now. But really what it does is this is just a permanent attribute on the color class. We can access it anytime. It's public, so we don't have to call a method to get it. We can just use the dot operator and grab it, and it gives us the color red, and we can now use it to set colors on things and to draw stuff. So pretty cool. So this activity got you a little more familiar with creating and using objects. We just went through all the steps. So make sure you write your reflection, attach in the text submission on Blackboard that you attach the Java file. And remember, this code review section doesn't apply to you anymore. Unfortunately, we're not in the class together, so it's kind of hard to do a code review. But I hope this explained aliases and how objects are stored in memory a little bit better, got a little more experience with creating them, and that you're feeling a little more comfortable now. So with that, I hope you all have a great afternoon, evening, morning, whenever you're watching this, and I will catch y'all later. Happy coding, everybody. I just wanted to show you what I've been dealing with while recording this video. Having a puppy does not make drawing in Java very easy. If you heard me kind of hesitating throughout the video, this is probably why. Gracie, you say hello to the people at home. If she can hold still. Oh! She's trying to type on the computer, so I'm going to let y'all go. Have a good week.